Lesson 8, asymptotes of rational functions. So as we look at asymptotes, as you kind of indicated, you guys already know a decent amount about asymptotes. So a lot of this is review, just kind of talking about all the different pieces and making sure they all go together. So process, this just kind of talks about the different pieces we need to do before we graph these. One, finding horizontal asymptotes. And notice there it says by finding the limit at infinity, basically you are looking at the in behavior, or the shortcut I would say is the powers. The highest powers is that's where my brain was going with that. So, 2, vertical asymptotes. That's by setting your denominator equal to 0. Hopefully it factors. That's going to make life the best, right? 3, finding zeros, and that is by setting your numerator equal to 0. So factoring and looking at the pieces there. 4, finding slant asymptotes. Oh, no. I don't remember. They come up a little bit in pre-calc. I don't remember how much we've talked about slant asymptotes, but we're going to talk about slant asymptotes, and that is if there are no horizontal asymptotes. So notice it says only do number 4 if number 1 doesn't exist. So slant asymptotes, because horizontal asymptotes are more about your powers match, look at your coefficients. Slant asymptotes are when your bigger power is on top. You end up with a slant asymptote. So we will look at that. It does include dividing numerator by denominator. Now, example 1, we're not actually graphing. It just says find the equation of the horizontal asymptote of that function, which I'm not going to bother to read out loud. What do you notice here? Okay. Higher powers on bottom. Because what are we looking at? We're going to look at the 3x to the 5th on bottom, 4x to the 4th on top, right? So when you look at those highest powers, of 4x to the 4th over 3x to the 5th, we want to note that the larger power is on bottom. What does that tell me when the larger power is on bottom?
Isn't it always zero?
Right? Okay. Horizontal asymptote is y equals 0. If the powers match, you're using the coefficients. If the bigger power's on top, we say no horizontal asymptotes, and that takes us to the slant asymptotes. Okay? And officially, what I should be saying here, do you remember the limit as x approaches infinity? This is really, my goodness, what is that? Okay, there we go. The limit as x approaches infinity, and then you end up, again, with that extra x on bottom. So, okay, let's get to graphing. What do you think?
Sure.
Example 2 is graph. So if we choose to go in their step order, gives me something to reference. Okay, number 1, horizontal asymptotes. What are your thoughts on horizontal asymptotes? I agree, 1/2. Notice they're being tricky, aren't they? Biggest powers are not the first necessarily. They're trying to trick you. Didn't trick up the girls, at least. So since it's x squared on top, 2x squared on bottom, so that is 1x squared over 2x squared. Yes, you do end up with a horizontal asymptote of y equals 1/2. Not too traditional here, is it? Normally on these, a lot of times we have y equals 0, but this one, the powers match. Okay, number 2, vertical asymptotes. What are your thoughts on vertical asymptotes?
It'll end up being plus or minus 2.
plus or minus 2. I agree. Officially, and we probably should have done this earlier, let's do some factoring real quick. On the denominator, if you factor out a GCF of 2, then you have x squared minus 4 left. And so then if you continue to factor, you've got the 2, and then x squared minus 4 is x plus 2 and x minus 2. So again, vertical asymptote is setting your denominator equal to 0. And we do end up with x equals 2 and x equals negative 2. I really should have moved this graph up so I'm not working at the bottom of the screen, but oh well, too late now. Let's see, what is 3? Zeros? What are your thoughts on zeros?
Well, yeah, factor.
Okay, so if we factor on top, there's a GCF of x. And I don't know about you guys, but if I factor that GCF of x out and I reverse it, you guys okay if I say x times x minus 5? That just works better for my brain. Maybe that's just me, but otherwise it's x times, here, you know what, I have to, oh no. Wrong thing. If I say negative 5 plus x there, I can still change it over here. There we go. Now, if it's x, x minus 5, what does that say as zeros?
0.
Yeah. We have zeros at 0 and positive 5. And that's from setting your numerator equal to 0, yes? Okay, what about number 4?
We don't need to worry about it.
Okay, we had a horizontal asymptote, didn't we? And so there are no slant asymptotes. So yeah, you get to skip step 4 when we have an answer for step 1. Okay, guys. Set us up a graph. These are the graphs that I tend to make big and long. As I look at labeling, we have to go minimum, what, 2 left and 5 right, if you will. So I put some tick marks, but I labeled some key points there that I know I'm going to use. I also technically need to label up 1, don't I? What's the first thing, one of the first things we have to put in there? We had a horizontal asymptote at y equals 1/2. Y equals 0 is the y or x-axis. So y equals 1/2 is the going to be parallel to the x-axis, halfway between 0 and 1, if you will. Vertical asymptotes at 2 and negative 2. Zeros at 0 and 5. I like to put points so that I can Remember to hit those pieces.
Yes. Or, no.
I would have said no.
It would just be x squared minus 5x.
Right. Because the lead term is positive x squared and positive 2x squared. So once I got it factored, I have all regular factors here. And so I would say no, it would not be reflected for that reason. Okay, now, to start this thing, where do we start?
Well, we have to be underneath our line of right 1/2 on the left. Underneath, right? Because we won't use the x-axis as the horizontal asymptote, right?
Well, we're going to start on the right. We normally start on the right on these. And this one, okay, so we have positive, right? So normally it tells us to start above the x-axis. And that's what it's telling us to start above the x-axis, not above the horizontal asymptote. It's telling us to start above the x-axis. So we're going to start above the x-axis, which happens to be below the asymptote. No, technically would not have a degree sign. And actually, people did put degree signs on there, and I just struck them out. But okay, something we probably need to talk about. I'm realizing. Okay, are you guys okay with where I'm starting here? Now, okay, so we're starting here, right above the x-axis, because it's positive as we're close to the x-axis. Now, what do I have to do?
Go to the left and go through the 0.
We have to go through the 0. And then after we go through the 0,
Stay underneath the x-axis until the asymptote.
yeah. I don't know if that's the best graph. I'm not really liking the looks of my graph there, but you get the idea. And that's the thing. It's a sketch, right? It's not going to be precise. Okay, now what? What happens at a vertical asymptote?
Since it doesn't have extra power on it, we would just start from the top.
Okay. If this came from x minus 2, right? If it was x minus 2 squared, then we'd stay down. But because it was just a power of 1 or an odd power, we're going to change signs. And so we're going to go up here and be positive, right? So we're starting, we ended negatively on the right of 2. Now we're going to be positive on the left of 2. Now what?
Go down, we have to go along the horizontal asymptote, but we can cross through 0, right? And go down.
Okay, so if you recall, vertical asymptotes we never cross. I can tell the look on Ethan's face. He's struggling with what I'm getting, Horizontal asymptotes.
Explaining this to me last year. I was so
Okay,
confused.
horizontal asymptotes determine end behavior. We will never cross the horizontal asymptote out here at the ends. Never ever. However, in the center of the graph, the horizontal asymptote doesn't really mean anything. Okay? It determines end behavior. So off at the sides, we won't cross that horizontal asymptote. Like it would stay always below this horizontal asymptote. In the center, we can cross through a horizontal asymptote. Okay? So that horizontal asymptote doesn't really mean anything right here. It determines end behavior. So we are going to cross down. We're going to cross down and go through the 0, and then run alongside the next vertical asymptote. Okay? And this 0 came from just a factor of x, yes? If it had an even power, then we would touch it and go back up instead of crossing through. But since it was x at first, we're going to cross it and go through. Okay, now what?
Since we did that on a non-even vertical asymptote, we can start from the top again.
Yep, we're going to switch sides again. We're going to start up here. And,
Just run down along the horizontal asymptote.
okay, this one, we have nothing else going on out there, right? No zeros any farther out, no other vertical asymptotes. So this is where end behavior matters. And we will not cross that horizontal asymptote. We'll run alongside of it. Are we good? If so, I'm ready to look at the next one. And get off the bottom of the screen where I think I want to use my whole screen on the VinQ and then I forget it's a pain to write at the bottom. But, oh well.
Yeah, that'd be a little uncomfortable, right? Seems like lean over.
Yeah, I'm like hunched at a weird angle and I feel all awkward being hunched at a weird angle in front of you guys but okay. Sample 3. You ready? Okay. If I go through my steps kind of like the way I did earlier, first item was horizontal asymptotes. Okay. I'm sorry, you guys are making me laugh there. Okay, no horizontal asymptotes because bigger power is on top. So because it was x squared over x. Okay, step 2 was vertical asymptotes. What about vertical asymptotes?
0.
Nice easy 0. X equals 0 because we set our denominator equal to 0 and that denominator is just x. Step 3, zeros. How do we do zeros?
So top equal to 0.
But does it factor? Okay. Because it's x squared plus 1, that does not factor. We can still set it equal to 0 because this will kind of tell you what's going on. If we set that equal to 0, you have x squared equals negative 1. And so you have an imaginary couple of zeros. So you do have zeros, I guess, if you want to go that direction. But we don't go that direction, do we? And so our answer for zeros is going to be none, because they would be imaginary. Step 4.
We hardly have a graph.
We got a long divide the numerator by the denominator.
Okay, so officially we are dividing numerator by denominator. And, okay, let's see. As we set this up, some things to think about. I'm dividing by x, so that goes outside, yes. Actually, we wouldn't even have to use long division on this one technically. But as I set this in here, I'm going to put x squared, I'm going to say plus 0x and plus 1. Again, we're only dividing by x, so it's not a huge deal here. But if you were dividing by, say, okay, so I guess in my notes I just looked, instead of just putting x out here, I kind of wrote it as if it was a factor, x plus 0. And I did that just to kind of demonstrate, okay, if you really had to use long division, like this is what we would do. Does this sound familiar a little bit? So when we divide x into x squared, in other words, what is x squared divided by x? That is x. Now, because we're dividing by 2 terms officially, or because this is a single x, we're going to put that x over above the second piece. Then you multiply. X times x is x squared. X times 0 is 0x. When you subtract these, you get nothing, right? And then you drop down the 1. except that x doesn't go into 0, does it? Or 1. And so this 1 is my remainder. And with a remainder, we say 1 over x. Now, I'm showing long division for the purposes of you need to see it. But keep in mind, guys, x plus 1 over x, that officially is my slant asymptote. Because it was just an x, we didn't really have to do long division here. Think about this. We had a single denominator. X squared divided by x is x. 1 divided by x is 1 divided by x. Now, when you think about graphing y equals x plus 1 over x, don't worry about the remainder. The basic slant asymptote that we're going to worry about graphing is y equals x. So traditionally, you take the basic part of the slant asymptote and graph that, and you drop off the fractional part. Okay? Now, shall we talk graph? Shall we talk graph without looking at the graphing calculator? It's Ethan that said we don't really have much to work with. Well, we still don't really have much to work with, do we? Put in what you know. We have no horizontal asymptote. We have a vertical asymptote at x equals 0. So our y-axis is a vertical asymptote. We have no zeros, so this graph will never cross through the x-axis. And we have a slant asymptote at y equals x. What's a line y equals x look like? Okay. Perfect diagonal line. Goes through 0, 0, has a slope of 1, right? Goes through 1, 1, 2, 2, 3, 3, 4, 4. I just eyeballed it. Okay. How do I make this work?
So we're starting from the right. Would we just start somewhere in between the slant asymptote and the x-axis because we're above the x-axis, right? But we don't know how far above. So we would just go to the right, and then I don't know what happens.
It's like a hyperbole kind of. Or...
Yeah, kind of. So we actually start above the slant asymptote is where we end up starting. So we end up starting above the slant asymptote, and what's happening is you're running along the slant asymptote, and then you approach this vertical asymptote, which tells you, say, hey, you can't cross me. You can't cross me. So then it forces you to go up, because I can't go down, because I can't cross the x-axis. And then we have a vertical asymptote. Well, what happens after you cross a vertical asymptote? You change signs, and so now it's a similar type situation down here. That is a typical graph that you see with slant asymptotes. Had it been a different situation, yeah, we could have maybe had to cross the x-axis and have our pieces over here and over here. It just kind of depends on the situation. I probably got that graph a little too low. I'll have to work to avoid it on my next one. Okay, one more. Let's see, step 1. Any horizontal? Of course not, right? Because part of the name of the game today is slant asymptotes. So no horizontal because we have the bigger power on top. What about vertical asymptotes? X equals 2 because you set your denominator equal to 0. What about zeros?
Plus or minus 1.
Okay, this time we can do this, yes, because it's x squared minus 1. And so you're going to have x equals 1 and x equals negative 1. I don't know why I didn't just write plus or minus, but that is from setting your numerator equal to 0. You can factor that as x plus 1 and x minus 1, or you can just set x squared minus 1 equal to 0. And number 4, your slant asymptotes. Now, it says long division. And by all means we can. But what is our divisor? It's x minus 2. It's a linear divisor. What other method do we have for dividing when it's a linear divisor? Synthetic division. It doesn't work if it's not a linear divisor, right? Synthetic will only work for linear, but you could use synthetic here, right? You either like it or hate it, but so if we're doing synthetic, since we're dividing by x minus 2, in my box is going to be positive 2, right? Because you said x minus 2 equals 0, so 2's in the box. My top row, what represents x squared minus 1? 1, 0, negative 1. Because you have to have placeholders here. Incredibly important in this situation. Drop the 1. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. Negative 1 plus 4 is 3. Are you guys okay with that? Synthetic is coming back to you. What equation represents this? Y equals x plus 2. And what is the 3? The 3 is it's your remainder. So officially this is 3 over your divisor of x minus 2. So y equals x plus 2 plus 3 over x minus 2, which what we're going to end up graphing is just y equals x plus 2. I don't know how well I'm probably going to end up running into that other graph, but oh well. Okay, let's see. What do we have happening here? No horizontal. Vertical asymptote at 2. And zeros at 1 and negative 1. So this is where I like to put my points here to remind myself to cross through it. Yes. And a slant asymptote at y equals x plus 2. Which means officially it crosses through there's an intercept of 2 and a slope of 1. So up 1, over 1, or down 1, left 1, down. It ends up basically going through 2 on both axes, doesn't it? Gosh darn it. That's really confusing. Sorry, guys. It's kind of lining up almost perfectly with my last asymptone. That's confusing, but
Maybe it's just like one big ass.
it does look like one big asymptone. I'm not sure I really wanted that, but oh well. It is what it is. We go with it.
Helps me understand that the asymptote goes on forever.
Because it really is going on forever. Okay, guys. Thoughts on what my graph is doing here?
Well, if we're going to continue the earlier themes of starting above the slant asymptote, we could start there, go down, then we'll hit the vertical and have to come back up, right?
Mm-hmm.
And then start at the bottom of the vertical, go up but over to zero, cross the zero, and then I'm lost after that because I don't know the rules with that. Because would it just go up the slant asymptote after you hit the first zero, cross over the y-axis just fine, and just go back down?
You don't even go all the way up to that slant asymptote. And this right here, these zeros, guys, are a huge key as to where part of my graph has to be, yes? Part of my graph is going to have to be starting down here alongside the vertical. I don't like that. Okay. Running up, hitting the zero, turning, hitting the other zero, and running down like that. Now, based on that, based on knowing that piece, you can kind of backtrack, can't you? If you didn't already do it. Vertical asymptote tells me to flip signs, so now my other piece is up in there. Okay.
You get the same type of looking thing.
Yeah, it's the same graph, just in a different, different positioning. But yes, it is very much the same graph. Note there is one change of a problem. Number 2 becomes 5 from 77.